So hey everyone, welcome back to my channel. I hope you guys are doing well. So today we are going to solve another contest question, which is a bi-weekly contest, and this one is the second question. So without wasting time, let's get started. So let's see what's the question is trying to say. Like the question is minimum operation to make binary palindrome. Okay, you are given an integer array nums. For each element, you may perform following operation including 0 times. Okay, increase num by 1 or decrease num by 1. Okay, a number is called a binary palindrome if its binary representation without leading 0 reads the same forward and backward. Okay, your task is to return an integer array answer where answer I represent the minimum number of operations required to convert nums I into binary palindrome. Okay, so let's see the example. uh, so what they are trying to say is we have given an array and we just have to convert our number to a binary palindrome, and we have to return minimum number of operations, right? For example, let's say 1. If we convert 1 into binary, which is 1, and if we see it is already an binary palindrome number, so we the number of operation which we required is 0. Let's see in case of 2, the binary representation of 2 is 1 0. If we see, it is not a palindrome because as we know, palindrome is something which reads same from backward and from front, right? But in this case, if we see 1 0 is different and 0 1 is different, that means 2 is not a palindrome number. So what we have to do, we have either two options, right? Either plus 1 or minus 1. We can perform this operation on every nums of I in order to make that particular element binary palindromic. So right now we have two. It is not a binary palindrome. So what we can do, either we can increment or either we can decrement, right? So in case of 2, what we can do, if we simply increment the value of 2, which is 3, uh, 3, let's see if it is a valid answer or not. If we convert 3 into binary, so it is 1 1, which is a binary, which is a palindrome. And how many operation we require? We require plus 1, which is just only one operation we require to convert 2 to 3, right? So this we have to do. Let's see for the in case of 4. As we see, 4 is also not a palindrome. Why? Because the binary representation of 4 is 100, but 100 is not palindrome. So how we can achieve it? Either we can increment or either we can decrement, right? Looking at the requirement, can we say that every time whenever we got a number, we're just looking for another number in which all the numbers are all the digits are equal, and we are actually dealing with binary, so we only have two digits, 0 or 1. So there is no case of 0 because we are incrementing or decrementing. But let's see what will happen. But the first thing which should notice is that we are actually dealing with only two digits, right? So in this case, don't you think I'm looking for a number which contain all digits is 1, right? So how can I achieve it? If I increment, like how many numbers I need to increment, like in case of 5, let's write it over there. Like 5, it's binary 001. 6, it's binary 110. It is again not a palindrome. But what about 7? 7 is 111. It is a palindrome number, which means how many operation we actually require? We require 3 operation to actually convert the number into its palindromic binary number, right? But is it our optimal answer? Let's write the answer over here. Our current answer is coming as 0 1 and 3. So does it actually the optimal answer for this particular test case? Let's see. In this case, what we have actually done, we have just incremented the values in order to get a palindromic binary palindrome number, right? But if you see, we also have a condition of subtracting one from it, right? So why not do some more thing? Like what if instead of here we are incrementing it, right? What if I decrement and make it 3? It is also a palindromic number. And how many operation I require? I require only one number of operation to actually reach at this point of time, right? So what we got through this, that we are not just assuming, or we are not just taking care of, like we are not including only the increment part in our answer, there may be a possibility that decrementing the values also gives us an optimal result. So thus what's the actual answer would be, it's 1. So this is our answer. So this is the basically what the question is trying to say. So how to actually think about this problem? So let's see the constraints. As we see, constraints are pretty low, not too high. So the length is 5000 and the nums I is itself 5000. So what we can do, if you think for any given number, what we can do, we can generate or pre-compute. If we pre-compute, like pre-compute the all the like pre-compute all the numbers, all the palindromic number. So for any one single number, we just have to find out the minimum difference between all the available answer, right? What I'm trying to say is, let's say I have stored all the palindromic numbers like 1, 3, 7 and 15, right? So I have pre-computed this, right? And now what I'm doing is, for every number, let's say my example is, so I'm iterating over my numbers. Let's say in case of 1 we are ignoring it. Let's take it with 2. 2, what we are doing it, I know I have this number of pre-computed values which are actually a binary palindromic. So I will find the difference between my current element and iterate over these elements and check which element gives me the minimum number of difference, and based on that I will take that element, like the difference between both of them. For example, let's see here, if I'm just not considering 1 over here, because 1, for example, my given elements are these. So what will I do? I just simply check uh, the difference, 2 minus 3 which gives me 1 difference, 2 minus 7 which gives me the difference of 5, 2 minus 15 which gives me the difference of 30. So I will take the minimum one, and as I know I have to either increment or decrement. So through this particular approach, I got to know about how many operations I actually required to convert my given number to a binary palindrome. And I do this for every number. So how the boilerplate code is look like, or the pseudocode, I iterate over uh, all the element of the array, right? And for the current element, for every element I have this pre-computed values. Let's call this as an answer or whatever. I iterate over this. Let's say the answer size, and for every element, for the every nums of I just simply have to calculate minimum of nums of I minus the answer value, which is actually stored inside this particular answer dot get I. It's just a boilerplate code I have written here, right? So I just calculate the minimum difference, and once the loop is over, I will store that particular answer in my result. So this is the basic idea behind the particular problem, like how to actually think of it. Because the constraints are very slow, very small, we can iterate for every element inside the pre-computed value. If the constraints are pretty high, then we can use like lower and upper bound using binary search. For every element we find the nearest element, and with that we are simply able to solve this particular problem, right? So let's see the code. So what I have been doing here is, so what I just created an answer where what I'm doing, I'm pre-computing the values, pre-computing the values, right? So that I can use them in order to find the my optimal answer. I have stored it inside it. What here is, I am checking like how to make sure the given number is a binary palindrome. So what I am doing is, let's say if the given number is 3, is n is equal to 3, for example. So what I am doing is, I am converting it into a binary string, and then checking it if it's a palindrome or not, right? So we are just running that particular loop, which is not running more than log n time, because every time we are like dividing n by 2, so it's almost a log n time because we are using two pointer approach. Here what I am doing it, for every element of num I am checking the minimum difference between my current minimum and the answer of jth and nums of I, and storing it inside my minimum variable, and at the end of the loop I'm storing that particular element inside my result array, right? And just running the code, see it is working fine as expected. Talking about the time complexity, so if you see, this is O of n, and this is O of n into the size of this O of n, and plus O of n into the size of answer, right? And how many elements are actually going to use, almost like n, right? And multiply by log n time, because every time we are executing is check particular function which are actually like while calculating it. So n into like log n, if we conclude it, O of n square log n would be the time complexity. Space complexity is of n, because we are storing the decomputed values. So this is it about this particular problem, and I hope you like the video. If you understand the concept, do let me know in the comment section. Do like the video, subscribe to the channel, so that I also get a little bit of motivation to make such more content. So this is it for this video, and bye bye, take care.